Okay, guys, I'm going to continue now and look at the number 7, and this is actually just a little piece of number 7. This was actually part of a product rule question, but I think that the question really came up with this one. So I'm going to look at how to factor this little piece of the derivative from number 7, and this was from Unit 5, Day 3. So there are solutions posted, but I had a question about the factoring step in here. So here, I've got a function and I've just rewritten that root x as x to the 1/2 on the bottom. When I do my derivative, f prime at x, and we're going to have the denominator, so x to the 1/2 times the derivative of the numerator, which is 1, minus the numerator, which is x minus 1, times the derivative of the denominator, which is 1/2 x to the negative 1/2, all over the denominator squared. So that's how we would do the quotient rule when we're doing the derivative of that function. And I'm just going to kind of simplify, clean this up a little bit. So that's x to the 1/2, and I'm just going to say this is minus 1/2 x to the negative 1/2 times x minus 1, all over, and of course x to the 1/2 squared works out pretty nicely, and we get just an x on the bottom there. So this goes back to that factoring issue with how are we going to bring out a common factor. I know I'm going to want the smallest exponent of x. So I've got x to the 1/2 and x to the negative 1/2. So that's my common factor, is the smallest exponent. So you have to kind of compare 1/2 and negative 1/2 and take out the smaller one, which is a little bit trickier when you're working with rationals compared to when you guys were in like grade 10 and 11 and just factoring with nice positive integers. So I really don't like that fraction inside of the bigger fraction. So you could do a couple things here. You can multiply everything by 2. So kind of multiply the top by 2 over 2, which would cancel out this 1/2, and you get a 2 here and a 2 on the bottom. I did this in the solution just by factoring out a 1/2, which I'm going to kind of model here. And then this is x to the negative 1/2. So my common factor here is 1/2 x to the negative 1/2. And then I'm going to look at what would be left when I common factor that out of the numerator. The x is still going to be in the denominator. So now what I really want to do is think about this piece times something has to equal x to the 1/2. So 1/2 times something has to equal the coefficient of 1 that's there. So obviously it's 1/2 times 2. Now we want, just like before, what exponent on an x could negative 1/2 plus something equals positive 1/2. So that's kind of my off to the side thought bubble. I wouldn't normally write this down, but just to kind of model what I'm thinking about. So I need some exponent on x that would add with negative 1/2 to give you positive 1/2. So of course that's going to be x to the 1. So this would be 2x to the exponent 1. Of course, I don't really need to put that there, but just to see where that exponent came from. And then I've got a minus, and be careful with distributing this negative. Super common spot for a mistake there. Now this whole thing, 1/2 x to the negative 1/2, has been factored out. So all I have left here is the x minus 1. So now what I have left here is 1/2 x to the negative 1/2, and then I've got 2x minus x plus 1. So that is what's left when I have factored that out, and it's all over x. Now, bringing this down, I do want to simplify, write things as a single fraction with positive exponents. So this would be, this stuff here would go on to the denominator, so I'd have 2 x to the 1/2 times that x, and on the top is what's in these square brackets here. 2x minus x is x plus 1. And then I can simplify using my exponent rules here, x plus 1 over 2x to the 3/2 if we add up those two exponents.